Okay. Yesterday we did a problem in class. Ice at negative 20 degrees, 1 kilogram of ice at negative 20 degrees, correct? And we said how much steam that has an initial temperature of 120 degrees Celsius is needed to melt that ice to bring the equilibrium temperature up to 0 degree liquid. Clear? Yes? Okay, now, so we said, we looked at this. We said, can you see this? Can you see this?
Yeah.
Yes?
Yep.
Okay, that, you see that? Okay, and then you see that, right? Yes?
Yes.
Okay, there's five heats. Yes?
Yes.
So the ice went from negative 20 solid to 0 solid. That's Q1, correct?
Yes.
And then it went from 0 solid to 0 liquid. That was Q2, right?
Yes.
And that was the heat gained side of the equation. The heat loss side of the equation was the steam going from 120 gas to 120 gas to 100 gas. That was Q5. That was the first transition. The second transition was 100 gas to 100 liquid. The third transition was 100 liquid to 0 liquid, correct? Special note. Q5, Q4, Q3, they were all negative. For instance, final temperature minus initial temperature. Yes? It was 100 was the final for the Q5. Recall Q5? The change in temperature would be TF minus TI. Final temperature is 100, initial temperature is 120. So that heat would be negative, correct? Which makes sense because it's giving up heat. So the steam is losing internal energy, so it would be exothermic, it would be negative. Now, Q4, where it gave up the heat of vaporization, would also be negative, but that's not mathematically negative. You have to make that negative because you know that the steam is giving up 540 kilocalories per kilogram, correct? Yes? And then the third transition, actually Q3, would be 100 liquid to 0 liquid, which would be 100 would be 0 final temperature minus 100 initial temperature, and that heat would be negative, correct? And that makes sense because that's also giving up heat, and it would be exothermic, correct? Now, we're going to do this in 2 or 3 different parts. Okay, I'm going to call this ice problem 4, part 4. And we're going to do subpart A, B, C, and D. Hopefully we'll get through it in 4 quick parts, okay? And this problem, we're starting at negative 30 degrees solid ice, 2 kilograms, and we're going to start off with the steam as 150 degree steam, and the equilibrium temperature is going to be 20 degrees Celsius. Correct? Now, look at this. So, do you see that the steam is going to have 3 transitions, Q5, Q4, Q3, correct? And the ice is also going to have 3 transitions, Q1, 2, and 3, correct? You see that? You all right with that? Okay, now, because I have to have the camera close to the board because of sound problems, I'm going to simply show you as a separate part the given information and the constants that we're going to be using, as well as what I just did, an introduction to the problem. Yes? So these are the constants. I'll go off camera, turn it off. and we'll go on to the next part. The next part, I will erase that and then go through the equations to solve the problem. Are you okay with that?
Yeah.
Everyone all right? Erica, welcome back. We missed you yesterday. I'm glad you had a good day yesterday. Erica went on a field trip, and she's that much better of a person as a result of that. Excellent. Excellent. Anybody else was not here yesterday? Okay, excellent. Excellent. So let's begin. Let's erase this and go on to the next part, okay?